Okay, today we're going to look at 5.8, Pythagorean Theorem. So Pythagorean Theorem has to deal with the right triangle, and that basically means there's going to be one right angle in the triangle. And this is marked with a square. So this is a right angle. It's a 90 degrees. So it's basically, vertical. This is the horizontal. Straight up is the vertical. And then we have two legs. We have leg A and leg B here and here. It doesn't matter which one is labeled which. And then C is our hypotenuse. And what we have is we can use the Pythagorean theorem, which is a squared plus b squared is equal to c squared. And with this formula, we can solve for any of them. We can solve for c or b or a, plugging in what we know, and then solving for the other one. And that's what we're going to do. This whole section is going to be about that. And so what we're going to do here first, it says find the exact length. Now when it says find the exact length, that means leave things as a square root. If they're a square root that's not a perfect square, if it's a perfect square that we can use somewhere, one of these values in our table, then we can take that square root and it'd be still okay thing, because that's going to be exact. But if you have to take the square root of, say, 32, then you won't do that. You'll leave it as a square root of 32. So leg, hypotenuse. So again, it doesn't matter which of them we call the leg we're looking at. So this maybe could be leg 1, this is leg 2, and this is our hypotenuse. So this would be maybe your leg 1. So you could say 7 squared is equal to, not equal to, but plus rather. And so we have 7 squared plus b squared is equal to 25 squared. Well, that's going to be 49 plus b squared equals, now if you don't know what 25 squared is, if you look over here, that's going to be 625. Now we want to solve for b, so we're going to have to subtract 49 from both sides. So when we do that on the left, we get b squared. On the right, what we're going to do is we're going to have to subtract. So we'll take and borrow. That's a 5. That's going to be 11. So 15 minus 9 is going to be a 6. And then 11 minus 4 is going to be a 7. And then we have 5 minus that's 0, or is 5. And so now we have b squared is equal to that. And so what we want is b, so b squared equals 576, so we want the square root of that, so plus or minus the square root of that, and so b equals, now here we have to think about it. If we're having a leg or a distance, can we have a negative? Not really. So always when we're looking at distances, we're really just going to have the positive square root. So that's going to just be the plus square root of 576. And if we look over here, that's equal to 24. So in this case, b is equal to 24, and our unit was meters. So that's how big leg 2 was if we consider b as 2. All right, so that's how we're going to do it. We're just going to solve using Pythagorean theorem and, just plug in values we know and then simplify. And so these are still of the same, find the exact length. And so what we need to do is we need to take and let's write up here so we don't forget, a squared plus b squared equals c squared. So we have 9 squared plus 12 squared equals c squared. Well, 9 squared is 81, 12 squared is 144, and that's equal to c squared. Now, if you need to, you can write 144 plus 81, or if we have our calculator, we can do it with our calculator. So, or I guess we don't have a calculator, never mind. But what we can do is 4 plus 1 is 5, then 8 plus 4 is 12, and then 1 plus 1 is 2. So 225 equals c squared. Now we take the square root of both sides, so it's going to be square root. Remember, we want a positive distance, so we don't have to have plus or minus. It's just going to be a plus for this one. And 225, can we take the square root of that? Well, it fits right here, so that's going to be 15. So c is equal to 15 meters. Okay, and that would be your answer. And if we took, 9 squared plus 12 squared equals 15 squared, does that equal, so you'd get, on the left, you get 225, and 15 squared is 225, so that would work. All right, so now we have, again, a leg and a hypotenuse. So if we let a be the leg 1, so that would give us 5 squared plus b squared equals 10 squared. And so we get 25 plus b squared equals 100. So now we'll subtract 25 from both sides. And so b squared is equal to 75. And so we need to take the square root of both sides. So we'll do that and we'll do that. So b is equal to the square root of 75. Now, if we look over here, there's not a perfect square root. So since it says exact values, we're just going to leave that as our answer. And it's going to be also in meters. So it's going to be the square root of 75, and it's going to be meters. Now, if they had said find the actual approximate square root to the nearest tenth, then we would use our square root tools we found in 5.7 and go from whatever the one below it is to the one above, count the numbers, and do all that. We'll do that here in a little bit, but for now they just want the exact number here. All right, so let's go to the next one. So we have leg 1, leg 2 again. So what we can do is we can just plug those in. And so we would have 9 squared plus 15 squared is equal to c squared. Well, 9 squared is 81. 15 squared is going to give us 225. And then it's going to be c squared. Now again, 225 plus our 81. That's going to give us 6. That's going to give us 10. So that's going to be 3. So c squared equals 306. And, oh, wait a minute. Yeah, okay, I'm good here. Leg 1, leg 2, okay. So then we want to take the square root of both sides. And so c equals the square root of 306. Now, does that actually have a square root over here? Well, if we look, it's in between 17 and 18, so it's going to be 17 point something, and they want the exact distance, and so this then would be our value we are looking for. Okay. All right. All right, now we've got ones where we actually have to do rounding because they want it to the nearest tenth. So now we have to use our skills of the square root and find the actual values to the nearest tenth. So we do what we've been doing. We're going to take 10 squared plus 16 squared is equal to c squared because we want the hypotenuse. So that's going to be 100 plus, now 16 squared is going to be 256, and that's equal to c squared. So 356 is equal to c squared. Well, we're going to take the square root of both sides. Well, 356, that's somewhere in between those two, okay? And so what we need to do is we need to say, okay, well, we have 324 is going to be 18 squared. And over here we have 361, which is 19 squared. And we're looking for 356, 56, which is what? That's what we're looking for, okay? All right, so 356 to 324, 356 minus 324, so that's a 2, that's a 3, and then 361 minus 324. Well, that's going to become a 5, so we have a 7, and we have a 37. So our fraction is going to be 32/37ths, and that's going to be what we guess as far as our decimal. So what we actually have to do is divide that out. So 37 goes into 32. We don't know how many times, so 0 point something, and it's probably going to be close to 9 because it's really close to that 361 down here. So if we take 37 times 9, that's going to be 63, and that's going to be 27, 28, 29, 30, 31, 32, 33. So 9 is a little too big, so that means it's going to be 8. And if we do 37 times 8, that's going to be 56. That's 24 and 5's 24 and 20, 29. So 296. Now we can subtract that off. So that's a 2, it's 11. So it's going to be a 4, 9, 10, 11. That's a 2. Bring down our 0. Now, only reason I do this is because I want to see if it's going to be greater than 5. Well, that looks like it's going to be greater than 5 because if I take 37 times, oh, let's say 6, that's going to be 42. That's going to be 18, 19, 20, 21, 22. And so that's going to be a 6. So my value I'm going to choose here is going to be, 0.86, and so if I round that up to 0.9, that might be my first choice, and then if it's too big, I can take it down to 0.8. So let's go ahead and take and say this is going to be 18.8 or 18.9. We're not sure. So what we have to do is multiply both of them and see which one is closer. All right, so I'm going to take the 18.8 first, and the 8 times 8 is 64, and 64 plus 6 is going to be 70, and 7 plus 8 is going to be 15. And then we have a 4051, then we have an 881, so it's a 4. That lines up there, so that's going to be a 13. That's 15. That's 3. So 353.44 after we move it 2 decimal places. So that's going to be less than, so that's why I figured it's going to be a larger. So we're going to go to try this one now. And so 9 times 9 is 81. And so then that's going to be 72. That's going to be 80. That's going to be 16, 17. And then we have 8 times 9, 72. That's 64. And 72, 64, 65, 66, 7, 8, 9, 1. And then 14, 15. And then we have a 9, an 8, and a 1. So it's a 1, that's a 2, that's a 7, carry 1, that's a 5. And so carry another 1, and it's a 3, so 357.21. So this one looks to be 353.4, so 353 and a half to there. That's going to be about 2.5, but this is only 1.2 higher. And so this one is actually closer. So my approximation is going to be that C is equal to approximately 18.9 meters. Okay, so this is again going back to using our finding square roots again, what we did last section, and applying it to the Pythagorean theorem. All right, so let's look at our next one. So we have again 2 legs, we just plug them in as they are. So we're going to say, okay, well that's going to be 6 squared plus 13 squared is equal to C squared. Well, 6 times 6 is 36, plus 13 times 13 is 169. That's equal to C squared. Now, if we add those together, 36, that's going to be 15, that's going to be 10, so that's going to be 205. So C squared equals 205. So we'll take the square root again of both sides. We only need the positive because it's a distance. Now 205, well, it's going to be between those two, 14 and 15. So it's going to be 196 up to 225. We have 205, so it's kind of somewhere here in the middle. And this again is 14, this is 15, so this is going to be 14 point something. All right, so if we go ahead and take our 205 minus 196, that's going to be a 1, that's going to be a 9. So then we have 15 minus 6 is going to be a 9. And then we have 225 minus 196. So that's going to be a 1, that's going to be 11, that's going to be 15, so that's going to be a 9, that's going to be a 2. All right, so we're going to have the 9 over 29 is going to be our fraction. And so now we need to know what is that decimal. So 29 will go into 9. Well, 0. So now if we take it times about 3, that should give us really close, because if we took 30 times 3, it'd be 90. So if we take that times 3, that's 27. 87. If we subtract that, that's going to be 30. So it looks like, hopefully, it's going to be roughly, I think, 14.3. Okay, just based on this, because the 1's not going to round the 3 up, whereas over here, that 6 rounded the 8 up to 9, and so that's why I thought we might start with 9, but I went ahead and did the 8 first, because then this one was over, so we had to go down anyway to make sure that the one below was under. And so now what we need to do is we need to take and say, okay, well, what is 14.3 times 14.3? All right, so 3 times 3 is 9, 3 times 4 is 12, and that's going to be 4, and 4 times 3 is 12, that's going to be 17, and that's going to be a 5. And then we move over one more, and that's 3, and then a 4, and a 1. So if we lined everything up correctly, and then carry 1, that's a 10. So 204.49. So that's very close to 205. But because we don't know what 14.4 is, the one right above it, let's try that. 4 and 4 is 16. 16 plus 1 is 17. That's going to be 5. Then 6, 7, 5 again, and then 4, 4, 1. So that's a 6, that's a 13, that's a 17, that's a 10, that's a 207.36. So that's too much. That's 2 over. This is just less, a little bit over a half under. And so we're going to say C is approximately 14.3. This time it's feet. And so that is going to be our distance for our hypotenuse. So if we're looking at the hypotenuse, so we said that this one was 6 feet, this one was 13 feet, and this one's 14.3 feet approximately. Okay. All right, what else do we have? Round to the nearest. Now we have to take that fraction and go out 2 decimal places, or 3 if we really want to do it, because here we took it out 2, we knew that was going to round up to the 9. Here we took it out to 2, we knew that was just stay 3, so now we have to take it out 3 to see what happens on the 100th place. And so now we have a squared, so that's going to be 4 squared, plus b we don't know, so it's b squared, and that's equal to 12 squared. So 4 times 4 is 16, plus b squared equals 144. Subtract 16. So b squared is equal to, now if we take and borrow 1, that's a 3. So that's going to give us an 8 and a 2 and a 1. And if we look over here, there's not a 128. So what we have to do is we have to actually go through all that stuff we just did again, figure out how far away it is, go ahead and multiply and do all that. And so it's going to be between 11 and 12. And 11 is 121, 12 is 144, and we're somewhere in here 11 point something at 128. Okay. So 128 minus 121, now that's going to be 7. And then over, now 144 minus 121, that's going to give us 23, it looks like. And so now what we need to do is go ahead and do that division. And so 23 into, now we'll do 7.000, because we want to go out to that third to kind of get an idea what's going to happen on the second position at the 100th. So how many times will that go in here? Well, 23 times 3 is going to be 969. So that gives us that. Subtract, we get 1, 0. 23 goes in there 0 times. And so now we have to go to the next one, bring that one down. That should go in roughly 4 times. And so that's going to give us a 12 and 8, 92. So subtract that, we get 8. So 30.304. So I think I'm going to try just the 0.30, and then we'll go from there to kind of get an idea what we have. Now, it could go up higher. It could be 3.2, because if we think about it, that, you know, if we say, well, that's going to round that up no matter what, we could do that. But we'll just start at the 30. So 11.30 is going to be the same as 11.3. So we'll just keep that 0 off to keep off one decimal multiplying. So that's a 9, a 3, and a 3, and a 3, and a 1, and a 1, and a 3, and a 1, and a 1. So that's going to be a 9, and that's going to be a 6, that's going to be a 7, that's going to be a 2, and that's going to be a 1. So 127.69. Okay, well, that's below, so we'll have to go up a little bit higher. So now we have 11.31 times 11.31. And again, this was just 0, 0. So really we had that there, but we didn't use it, because when you multiply by 0, it's going to be 0. So we dropped it. Now if we take and multiply this, that's going to be 1, 3, 1, 1. Then it's going to be 3, 9, and then it's going to be 3, 3, and here it's going to be 1, 3, 1, 1, and then 1, 3, 1, 1. We ran into our next one, so hopefully we don't lose track. So it's going to be a 1, that's going to be a 6, it's going to be 11, so it's going to be 6, 7, 8, 9. Then that's going to be 3, 6, 7. That's going to be 2, and then a 1. All right, so we move it 4 decimal places, 1, 2, 3, 4. So 127.91. So that's still under, and we only went up just a little bit. So that means we're going to have to try the 11.32 as well to make sure that it's not going to be the one that's going to be, right on the money. I'm thinking that this one would be pretty close, but this one could be even, pretty close too, but it could be on the high side. So we have to try it. So 2 times 2 is 4. 2 times 3 is 6, then 2, then 2. That's going to be 6, then 9, then 3, then 3. And then the next one over, so that's that. And then the next one's going to be 2, so that's going to be 2, 3, 1, 1. And then we have 2, 3, 1, 1. All right, so we have a 4. Then we have a 12. Then 10, 11, 12, 13, 14. We have 6, 7, 8, 9, 10, 11. 6, 7, 8, 2, and 1, 4 places. So 128.14. So this one is 0.0, 7, like that with that. But this one's 0.14. So this one is the closest. So we'll say leg 2 is approximately 11.31, and we're back to meters. And so that would be our length. And so again, if we're looking at it on the triangle, that was 12, that was 4, and this is 11.31. So that's going to be how it would look. Okay. All right, so let's do another one. Okay, now we have an application problem. So with application problems, what we're going to do is we're going to have to draw a picture to kind of see what we have. And then after we draw our sketch, then we can kind of go from there and get what we need. So it says a base of a 24-meter long guy wire is located 10 meters from the base of the telephone pole that it's anchoring. How high up the pole does the guy wire reach? So we're going to have some pole. And 10 meters away from the base, we're going to have the guy wire attached to the ground. And then it's going to go up the pole. I'm not sure how far up. It doesn't say it's going to go all the way to the top, so we'll just not draw it all the way to the top. And the guy wire is 24 meters long, it said. This is 10 meters. And so what it means is we're looking for this value here, x, or if we're using ABC, this could be our A. So if we want to use ABC, we'll use that as A. So that's going to tell us we have A squared plus 10 squared equals 24 squared. Well, A squared plus 100 equals, and then 24 squared, if we don't know it, that's down here in the corner, which again, you're going to have this here 2-column thing for the test, and that's going to be 576. So 576. So if we subtract 100, A squared is equal to 476. Now we take the square root of both sides, and again, we only want the positive because we're looking at a distance, from here to here is a positive distance. And so what we need to do then is we need to look on here, 476, well, that's going to be somewhere between here, and this one also asks to the nearest hundredth, okay? So we're going to go from 441, which is 21, up to 484, which is 22, and we're somewhere in between at 476, so that's going to be 21 point something, all right? So what we need to do is we need to take 476 minus 441, and that's going to be a 5, that's going to be a 3, and then we have a 484 minus 441, so it's going to be 43, so it's going to be 35 over our 43, and so we need to figure out that. All right, so dividing those out, all right, so the nearest hundredths will have to go here, and we'll go one more. And this time, what I'm going to suggest is what we saw last time when we had 3 even though this is smaller, what we did is we ended up rounding up to 1. So if we get 1, it's even smaller than, if it's just anything larger than 0, basically I'm going to round up to the 100th. And so what we'll do is we'll go ahead and do that. And so 43 times what will get us there. So how about, I don't know, 43 times 8. That's going to give us 32 something. So that's 24, 32, 33, 34. So that works. 34, 4. Subtract that off. That's 6. Bring down our 0. That's a 1. That's 43. Subtract that off. That's going to be 17. Bring down a 0. That's going to be close to a 3, I believe. So 43 times 3 is 9, 12. It might be 4. How about that? Let's try 4. 43 times 4. That's 12, 17. It's between 3 and 4. So we'll say it's 3. But again, I'm going to round that up to the next higher one just because I think, if we did what we did last time, it's going to have 3 multiplications. Hopefully this will drop it down to 2 only. So what we need to do then is take 21.81, or 2, yeah, because we were going to say go up 1, so we're going to say we're guessing it's 21.82. So if we multiply that, 2 times 2 is 4, 2 times 8 is 16, 2 times 1 is 2, plus 1 is 3, 2 times 2 is 4. We have 8 times 2, that's 16. Then we have 64, 65. And 8 plus 6 is 14. 8 times 2 is 16, plus 1 is 17. Now we have 1 times 2 is 2, then 8, then 1, then 2. And so that was 1, that was 2. So now we have 3 spots, so that's here. Now we're at, that was 1, 8, and 1. And so we're at the 4, then the 6, then the 3, and then the 4. Add now 4, that's 12. That's 5, 6, 7, 8, 9, 10, 11. That's 8 and 8, 16, 17, 18, 19, 20, 21. 7, 8, 9, 10, 16. 3, 4, 5, 6, 7, and then 4. All right, so move over 4, so it's 476.11. So that's 476.112. So that's a little over. So now what we have to do is we have to actually go one below. So 21.81 times 21.81. So 1, 8, 1, 2. Then we have 8, 64. That's going to be 14, 15, 6, 14. And so that's going to be 16, 17. And then we're here now. So that's going to be 1, 8, 1, 2. And then here we'll have a 2, a 16, a 3, and then a 4. Now if we line them up, 1, 16, 4, 5, 6, 7. That's 10, 16. That's going to be 7 and 7 is 14, 15. And that's 3, 4, 5, 6, 7, 4. 475.67. That one's too low because it's greater than 0.1 off. So we're saying then that A is approximately to at least to the 100th, 21.82, and we're in meters again. All right. So that's going to be our answer for that one. So that's going to be our height that is up the pole over here on the left side. That's 21.82 meters. All right, so the last one here. An animal trail runs east from a watering hole for 12 kilometers, then north for 5 kilometers. Then the trail turns southwest on a direct path back to the watering hole. And so what we need to do is go ahead and draw what we have. So if we write what we have as far as our directions, so this is going to be the hard one for many people, that if you remember your directions, if you say north is up, that means south is down. to the right is going to be east, and to the left is going to be west. So that's our directions. So if we start at some watering hole, we'll call that W. An animal runs east from a watering hole, so it's going to go this direction. Then north, so then it runs this direction. Then southwest, well, southwest is going that way, back towards the watering hole. That's going to be what our triangle looks like. And it says it ran 12 kilometers here, then it ran for 5 kilometers here, and then it wants to know how long is the entire trail. So first we have to figure out what that is, and then we have to add up all the sides. Okay, so that's not too bad. So what do we know? Well, we know if that x is actually a c, we'll call that c squared is equal to, we'll say that's c, and that's going to be 12 squared plus 5 squared. So c squared equals 144 plus 25. Well, c squared equals, that's going to be 169. So we'll take the square root of both sides. And again, we want only the positive, so we'll have that. Well, guess what? 169 is a nice number. That's 13. So c equals 13 kilometers. So that's equal to 13. So now the perimeter is the entire trail. So we just take and add all those together. So perimeter is equal to 12 plus 5 plus, and then we had our last number, which was 13. So that's 8, 9, 10, 1, 2, 3. So the perimeter was equal to 30 kilometers. Okay, and so that's how far the animal went when he went first east, then north, and then back southwest. All right, so that's 5.8, which is what we finish up for chapter 5, and we'll go to chapter 6 next.